Folks, we just cruised through that scope episode. We are going to go into the testing and debugging episode. So I just wanted to give you a little bit of an intro. I'll see you there. At the hotel, motel, Holiday Inn. Okay, unit test. Guys, we're at the hotel, the motel, the Holiday Inn. All right, so welcome back. We're going to cover unit test and debugging in this chapter. Unit test. Up until this point, all the coding lessons you've completed have been testing you based on your code's console output, what's printed. For example, a lesson might expect your code in conjunction with the code that we provide to print something like this: Armor 2, Health 18. If your code prints this exact output, you pass. If it doesn't, you fail. So test, we can kind of set up the parameters of here's some inputs. What's our expected output? Does the function do that? Or does the unit do that? Does the component do that? And that's unit test. So let's see, you'll encounter a new type of lesson in transparency. I actually haven't used too many unit tests on the front end. I've done it a fair amount of times. They have testing libraries like Jest and Cypress. Then I know Python has a bunch of, VS Code and a ton of testing tools are out there. So let's keep reading. These unit style lessons or unit test style lessons will test your code's functionality rather than its output. Our tests will call functions in your code with different arguments and expect certain returned values. If your code returns the correct values, you pass. If they do not, you fail. Your code is stinky and it fails. All right, so there are two reasons for this change. One, it's more realistic. In the world, you don't know people's inputs. You just want to give them random inputs, see the outputs. You want to test random things. Okay, you can also run your code and debug it with a print statement. Sweet. Complete the total XP function. It accepts two integers, level and pass. There are 100 XP per level. Total XP should convert the current level to XP. Then add this current XP to the XP to add arguments. Return the player's total XP. For example, if a player is level 1 and gains 100 XP, they have 200 XP. If a player is level 2, they have 250 XP. Sweet. Guys, this seems straightforward. So they should have 250 or 450 total XP. If a player is level 170 and gains 590 XP, they should do 17590. So you get 100 XP per level. So we'll return level times 100, right? Plus XP to add. It seems to work. And I'm not sure on the PEMDAS functionality here, but I think that's what we need. So expecting 250. Sweet. All right, let's try. Look at that, folks. The pass keyword is a way to tell Python to do nothing. You'll need to replace it with your own code. Okay, so just remove the pass keyword. Wait, what did it say about main tests? Oh, we had a test file. Okay, sweet. So this is how it does testing. See, it's a ton of stuff. So this is why testing is a little bit. Many teams I've been a part of, even recent teams I've interviewed for, they don't really integrate very many testing on certain projects, especially smaller startups, bootstrap companies, things like this, where you're basically going as fast as you can to product delivery, and upper management sometimes is completely ignoring tests. They're like, hey guys, we don't really need it, but you really do. You really do need unit tests, integration tests, and end-to-end tests can be a little bit tricky, but unit testing is deeply important, I think, in software. At least to some degree. And yeah, for the companies I've been a part of, sometimes I'm not saying they mean to overlook it or mean to like not have it part of their systems, but it's something that just takes time. You could see that last file was huge on test cases versus like, well, here's the function we need to build. Here's the test cases around it. So, okay, so let's move forward though. It's still important to understand testing when you need to do tests. Okay, so two lesson types. As we talked about, there are two types of coding on lessons or coding lessons on boot.dev: console output lessons and unit test lessons. Console output lessons, only one file of code, usually with a comment explaining where to write your code. When you submit your code, it's the console output to match the expected output exactly to pass. Debug print statements will cause your code to fail submission, so remove them before submitting. Okay, unit test lessons, two files of code. You got your main and the main test. You can read these tests, but you can't edit. When you submit your code, the return values of your functions must match the expected code exactly to pass. A console output is ignored. You can leave print statements in your code Which is more common? Okay, so you can leave console statements in your code, I think in unit tests. Sweet. Debugging. When you're working as a professional developer, you'll likely write code or typically write code on your computer and test it by yourself before it's deployed to users. That first part of the process is called debugging. You write some code, run it, and if it doesn't work, you fix it. You repeat this process until you're confident in your code that it works as expected. Okay, so run versus submit. Run is for debugging. The submit is like pushing your GitHub repository to your main branch, I suppose. So first run, then submit is what I'm seeing here. So basically they're kind of reiterating the development cycle is slow down, write your code, make sure it runs, and then you push the branch, and then you push the code. Okay, so complete the obviously in an emulator where code is all in a controlled environment here, a little different. But when you have prod, when you have just going to be deployed and things like that, it's important to a few steps in your pipeline before pushing to production. I do a lot of scripting commands, and before pushing, I'll have a bunch of tests, type checks, editing checks, formatting checks, usually about 3 or 4 things of just like make sure it's decent code quality before it even gets submitted to the pipeline, and then even from there should be at least a test or two. And there usually is built out of the box with a lot of these deployment mechanisms. But okay, so assignment: complete the task. Take magic damage function. It should return the new health after calculating how much magic type damage the player takes. Here is a description of the arguments. Health is the player's starting health. Okay. Resist is the player's resistance to the damage. Amp is the magic amplification. This increases the damage they deal as a multiplier. The spell power is the base damage of the spell. First, let's calculate the maximum damage inflicted by multiplying the spell power. So we'll say max dam or max damage equals spell power times amp. And then what we want to do is subtract the actual damage, right? Equals resist, subtract max damage by resist, right? Sweet. And then we want to return the health minus the actual damage. Let's see. Expecting. Ooh, guys, first take Drake over here. Golly. Should have submitted before making sure I made that statement, but awesome. Looks like we got her done. I hope that makes sense. Makes sense to me. Learning effectively. This course is about to get a bit harder. I imagine. We've been able to cruise through some of these lessons effortlessly, or hopefully effortlessly. So let's hope it continues. But I have a hunch it will not. This seems to be the turning point. There's no way around it. If programming were a walk in the park, everyone would earn 6 figures as a software engineer, but it's not. And to succeed without getting stuck and frustrated, you need help on learning how to learn. Okay, so process for solving hard code problems. Read the lessons first. Figure out the examples before writing your own code. Read the assignment. We've been good at that. We've been cruising along perfectly fine, adequate pace. This is great. This is great, guys. If you're following these lessons at this point, this is fantastic. We're just keeping it easy. We're just walking through the steps, reading the assignment, taking it bit by bit, enjoying the walk, enjoying the journey, enjoying the walk in the park. Start writing the code. Step 3. Add print statements wherever you need them. If you're writing a ton of code, add print statements in between all the code. We'll definitely be doing that, by the way. So I'm very excited for that. Submit the code. Okay, so if the assignment you're working on has unit tests, no need to remove them, and compare your code to the instructors. Okay, sweet. They missed use ChatGPT in here. I didn't see it. I swear I should have seen it. Okay, so you'll be penalized for peeking at the solution after you've successfully. I don't imagine you will. That seems a little bit arbitrary. Learning effectively. Okay, so boom. Let's see, process. Okay, that's the same stuff. So temporarily adding print statements is a good way to submit the code, quickly test and debug small pieces of code. Boom. I think so. That sounds about right. When you're stuck, what should you do first? Whine on Twitter. Absolutely that. Ask Boots a question about your code. Who's Boots? We'll ask him. Who's Boots? All right, so debugging practice. I want to walk you through a approach on how I write code, complete with debugging steps. Guys, I know half the time too, I'm like heart reading the instructions, just like I'm getting the overall structure and then just moving on. So that's sometimes software as a whole too, is you got to get the overall structure, I know they say the devil's in the details, but sometimes it's you just need the bird's eye shape of something like that. That's the biggest thing on my channel is zoom out. Like that's the biggest thing I'm always trying to keep the energy about with software engineering is like, don't get so freaking. Sometimes you have to, I definitely get that way when I'm writing software, learning stuff, but biggest thing I've noticed, especially in the software engineering space, is people are very much this way, and they're very zoomed in on stuff. And sometimes when you're building, and guys, I know this is tangential to the program or the lesson at hand, but it's a very good teaching point, is when you're building stuff for a business, right? Fundamentally, you need to have a bird's eye scope on what's going on in the business. And if you're spending all this time, oh my God, I'm writing this input field for this company and it's got to be this and this and so perfect, and then the company's like, hey, we don't even have forms on our product. You spent all this time super focused on this thing, but if you just stepped back and zoomed out, you wouldn't have had to spend 80 hours on that one thing. You could have just not done it from the get-go. So it's the best engineering is the code you don't have to write. And I've got this loose demeanor that I know irritates people all the time in the software space, but it's actually out of strong competence, not out of incompetence. And it's elusive. I'm not encouraging to and maybe it's just maybe my demeanor as well, but it's partially by design. It's to make sure I'm like relaxed all the time whenever, because I work all the time, like all the time I'm writing software, by this channel, by the SaaS products. I hope you guys kind of understand. I'm writing software all the time, but I cannot write software all the time if I'm just like beeline focus on every little colon, every little thing. Like you have to be able to zoom out. So I just wanted that as a teaching point, with obviously how I'm going through the instructions, how I'm kind of, just floating through and just kind of like you just enjoy it a bit. Just try to zoom out a bit. Granted, that's a lot easier said when things seem to be a bit easier. So we'll see how much I keep that when things get a little more granular. Okay, so the goal is writing small amounts of code and then test each bit of code to make sure it's doing what we expected from moving on. Trying to write entire programs at once is a recipe for disaster. The goal is to write a few lines, test them, write a few more. Small incremental improvements. Let's complete the unlock achievement function. It accepts 3 arguments before XP, what's that? Achievement XP, is that what that's supposed to be? It should return 2 values. This player's XP after achievement is unlocked, and the sum before and achievement XP. So alert message that says you have reached. Boom. Okay, so let's see. Okay, so I want to do an F print statement is what I believe they're called. All right, so boom, we have this achievement unlocked, and we have achieve name. Sweet. But let's keep reading what else we need. So let's start by running the code in its current state. Okay, let's actually go back. Let's do that. So we'll run the code in current state. We'll see what it says. Indentation error, expected indentation after block. Okay, looks like we're getting nothing. So what it suggests is return none and none. So let's at least fix that. So it fails the test, but we can at least run the code. Okay, so run the code once again. This time you shouldn't get a syntax error, but your test should fail. We see that here. So let's fix that. Let's start by calculating the XP of the achievement. So it looks like they did all the hard work for us. That's very lovely. Okay, so we have after XP, looks like before XP minus achievement XP. So, okay, run the code again. This time you'll see that after XP value is printed on the console. So we're using that print statement to kind of slowly test and debug. Once that's working, okay, we will return the XP. Let's see. We need to return 2 values. So you can see it's expecting 250, but we have actual 150. So alert equals, now that we have the after XP value, we can alert the achievement here. So basically what it's saying is let's just build one thing at a time, and then let's print it after we build it. Show the print statement. See the achievement here, the actual XP. Still fails the test case, but we're actually building, okay, one little bit at a time. Run the code. Is this console or is this output what you expected? We want the alert to say achievement name. So we need to change that. So we need to say achievement name, or achievement unlocked, excuse me. All right, so now that the test case is, well, I think this is supposed to be +2. This is not supposed to be a negative. Sweet. So achievement unlocked, expecting 250. And what do I return here? Alert, I imagine. Let's remove the print. That's the actual thing that we needed. All right, cool. So it's trying to break down, that was kind of a clunky way of doing it, but it's trying to break down that logical, like one step at a time of here's what you need. Let's print that out, see where we're at. Let's tweak on that new movement, and then let's do it again. Do it again until you're completed. What is a stack trace? A stack trace is a scary looking error message that the Python interpreter prints out to the console when it encounters certain problems. Stack traces are most common, at least for you right now, when you're trying to run invalid Python code. You need to get used to figuring out scary messages as a programmer. They're not that scary, guys. They're just a little message. So go ahead and run the code in the current state, and it'll look like, oh my God, that is terrifying. That is scary. Woo! Scared me right out of my seat. Scared me right out of my seat. Okay. So this is a standard header that's just letting us know the Python traceback that's being looked at. So it's the most recent call. Looks like line 5 in the file string and line 1 in module. Okay, so this is exactly the start of the trace. These strange exec and string files don't really exist. The Python interpreter is letting us know about them because they have to do with how your code is executed in the virtual browser-based environment. File home private, that's where we're calling this file from here. Okay, so in this case, your interpreter was executing the code in the main.py file. Message your F string. Oi, message the F string. Sweet. This is a lot of code that caused the error. So this F string right here needs to be a print, I believe, and the indentation doesn't match. So if we do that, okay, sweet. We fixed it, guys. We fixed the code. There should be code formatters too, and we'll set that up in VS Code when we get there, where you have prettier, you have stuff like that, where when you press save, it'll auto format, handle the indentation, stuff like that. Because you don't want to handle that by hand. That's just annoying to deal with. But okay, so in Python, numbers without a decimal part is called an integer. Just they are called. Oh, guys, wait a sec. We're on chapter 6. Hold on, and we're level 9. Hold the phone, folks. We just cruised through some good learning there. I hope there's some good lessons. I will see you on the next one. Finger guns. All right, bye.